Yeah, and thanks for coming out and being here with us tonight. So after Ron's talk, this is the last thing I promise, and I'll stop talking. After Ron's talk, we are going to have the results from the honey competition. So you have to stick around and see who wins this year for the most coveted honey. And then after that, at the very end, we're going to do some door prize draws. So if you want to win some of those awesome door prizes, you're going to have to stick around and take it all in. All right, so here's Ron.
See, can everybody hear me? Yes. I'll try to adjust this a little bit here. And just want to thank everybody for the fact that I'm able to be here this evening. It's a real honor and a privilege to be able to address you guys. And I do realize that I'm here mostly because you needed something to stall time while the judges are working in the back room. But it's still a lot of fun for me. And I hope you get something out of this. And since we're doing a honey judging tonight, and everybody in here is somehow associated with beekeeping and producing honey, I thought it might be kind of neat to talk for a change about the stuff that you're actually selling and what's in honey. And one way that we could approach that was to look at trying to figure out what's the world's sweetest honey. And I think a lot of people probably don't realize that there is such a thing as the world's sweetest honey. Because you would think, yeah, you know, honey is honey, and sugar is sugar, and it's pretty homogeneous. But in fact, it's not. There is such a thing. We're going to find that by the end of the evening. We're going to find the world's sweetest honey. But to start with, I'd like to give a little bit of a spoiler alert. The sweetest honey in the world is not produced in our area. Instead, we have to settle for the best. This is some incredibly good honey in this picture. It's produced by Mike Murray and Brenda Peach up in the foothills about 50 kilometers from where we are right here. And I think it's the best honey in the world because it's the Goldilocks honey. It's not too sweet, it's not too bland, it's a really nice honey for almost any use. The sweeter honeys have more fructose in them. And fructose isn't one of the best sugars for us, but and it's also, the sweetest honeys just tend to have a really kind of a sharp taste in my mind. But there are people who would prefer the type of honey that we're going to be looking at here in a few minutes. Okay, so honey varies in sweetness. You probably have traveled around and bought honey samples from different places, and you know they taste differently because they have different chemicals in them to give them different flavors, but they also have different levels of sweetness in them. And those sweetnesses are determined by the ratios or the amounts of the basic sugars that are in honey. Honey consists of, in order of sweetness, consists of fructose. Most honey is about 38% fructose. Sucrose is next in sweetness, and most honey is only about 1% sucrose. Then there's glucose, which is not quite as sweet, and it makes up about 34-35% of a typical honey sample. And there's a sugar called maltose. We're going to look at all these in detail. Maltose is the least sweet, and a lot of you probably haven't heard of it before, but if you make beer, you might know malt sugars from that. But we're going to look at all of these, and we're also going to investigate the fact that different floral varieties of honey, like alfalfa or canola, they have different ratios of these sugars. So that honey which has the most fructose and perhaps the least maltose is going to have a chance of being the sweetest honey in the world. Surprisingly, all plant sugar starts out as sucrose. Sucrose is common table sugar. So you look at cane sugar, 100% sucrose coming out of cane sugar. Maple syrup is actually 97% sucrose. These sugars are the sugars, the basic sugars that plants manufacture. They break down into the glucose and the fructose, to the principal components of honey, through a chemical reaction. So this big molecule up here at the top, I mean, this is going to get a little deep for some people, but I think we kind of want to know a little bit about its sugars in the honey because you're selling that, and why not know something about what your product is. So this big molecule up here is a sucrose, or a table sugar molecule. And if we could split it apart, it will no longer be a disaccharide, but it will be two monosaccharides. One of them will be glucose, and the other will be fructose. So plants produce sucrose, and enzymes split it into pieces. So let's look at the sucrose molecule just for a minute. It has two rings. One is a hexagonal ring and the other is a pentagonal ring. The rings are mostly carbon, that's the gray in here, and the red is oxygen. So if we count the oxygen atoms in these rings, we've got 1, 2, 3, 4, 5, and 6. So this ring has got 6 oxygens associated with it. On the other side, we've got 1, 2, 3, 4, 5, and if I count the same one again, we've got 6. So if we want to split this in two, we're going to need some help because we need an extra oxygen. That extra oxygen is going to come from water, because water, of course, is H2O. So it's going to come in here, it's going to join up, and with the help of an enzyme, the enzyme is just a catalyst. The enzyme doesn't change. It can do this over and over and over again. It can take more sucrose, bring it in, mix it with an enzyme, mix it with a little bit of water, and we can split it apart, and sucrose becomes 2 molecules, glucose and fructose. And these are the basic components of honey, fructose and glucose. Now they vary a little bit from plant to plant because some plants, even though they all produce sucrose as their main sugar, some plants actually add enzymes inside the flower blossom. And those enzymes start to break down these sucrose molecules into glucose and fructose. So there are plants that the bees visit where they bring back 100% sucrose and the bees go to work converting it. There are other plants that start the process. And some of them break down the glucose and fructose out of the sucrose, and then things happen, even at the plant before the bees get to it. Some of the glucose disappears, it gets reabsorbed by the plant. Some of the fructose falls out on the floor. So we have different balances. By the time the bees reach the flower, the nectar is a little bit different. Not only is the flavor different from the chemicals that are in the nectar that are secreted by the plant, but the amount of sugars are different too. So just to wrap this part up, sucrose plus water, working with enzymes, gives you glucose and fructose. And again, surprisingly, glucose has got exactly the same chemical formula as fructose. They both have 6 carbons and 6 oxygens and 12 hydrogens, but the difference is the structure. And because of the structure, fructose is twice as sweet as glucose. Okay, that ends the organic chemistry portion of tonight's program.
Is there a test?
There's going to be a quiz. So plants produce sucrose, okay? We've got that clear in our heads. Bees and flowers both add enzymes that break the sucrose into those simpler sugars, which are mostly fructose and glucose. And these, because of this breakdown by the bees and flowers with the enzymes, you can legitimately tell your customers that yes, honey is better for you than table sugar. Honey is better than sucrose, because if you eat a tablespoon of sucrose, your body is going to have to generate those enzymes and do the toil and work of breaking down those sugars into stuff that your body can actually use, because your body can use as energy the fructose and glucose. They both come from sucrose, but they've been pre-digested, as I like to say, by the bees, so that they're better on us. And we've known that they've been better, that honey is better for us for a long time. 3,000 years ago, most of you have heard this, eat honey, my son, for it is good. Well, this is my son, about 10 years ago, and he's eating honey, and you can see it's been good for him. Okay, so with all this in mind, we're kind of beginning to understand how honey can have different levels of sweetness. Because fructose has a registered value for sweetness of 163 compared to sucrose being 100, glucose 74, and maltose 40. What this means is that if you were to take a little bit of sugar and dilute it into water, there would be a certain amount that you would need before you could taste the sucrose. You wouldn't need as much if you were putting fructose into the water. You actually need about 63% less. You would need more glucose and a lot more, like 2.5 times as much maltose before you would say, yeah, this is sweet. This was all figured out about 100 years ago. 100 years ago, around 1915, there were a group of research scientists at the University of Minnesota, and they got a bunch of undergrads, volunteers, unpaid, sticking out their tongues, getting little droplets of dilute sugar, and these scientists recorded what it took, how much concentration it took of each of these types of sugars before they could detect it. That's called the threshold taste level. So they did the threshold taste level for these different sugars, and they arbitrarily assigned the number 100 to sucrose. And they could have called it 1,000, they called it 100. They used sucrose because even in 1915, people knew what table sugar was. They didn't know so much what fructose or glucose or maltose were, but they could compare that to sucrose. And this was really groundbreaking experimental work that people who work with food, especially big packers and producers in those days, they needed this information so that they could formulate their foods in a way that people would have it standardized and have the same thing all the time. So these scientists working at the University of Minnesota, research scientists, teaching, correcting, marking papers, they were never called professors. Would anyone here like to guess why in 1915 the people who discovered the levels of sugar, the very fundamental information, were never professors? You're right, they were women. Yeah, and women couldn't be professors in 1915, at least at the University of Minnesota. So now we're almost to the point where we can come to the answer, because we know that different types of sugars have different levels of sweetness, and if we know chemically how much fructose is in one sample, how much glucose, and it varies from flower to flower, or not definitely from flower to flower, but from floral type to floral type, then we can calculate and figure out what the sweetest is. But if I did that, the guys judging the honey would be we'd all be sitting here waiting. So I'm supposed to talk for about an hour. And so we're going on. Those same people, those ladies, those women who are the scientists, they found that it takes about 1 part of sucrose and 150 parts of water before people notice that it's sweet. Honeybees are a lot more sensitive. It only takes about 1 part in 1,000 for honeybees to sense sweetness. And honeybees sense sweetness with their tongues, with their antennae, and also with their feet. They can stand in honey and tell you that it's sweet. So they have all those things, plus they're a lot more sensitive when they taste it to know that it's sweet. Humans, of course, only taste with their mouth and sometimes their hands and their chin. What about cats? How much sugar would you have to put in like a liter of water before a cat would say, yeah, this is sweet? Anybody know the answer? Cat lovers? Of all the animals I've ever heard of for sensitivity to sugar, cats are the only ones who cannot taste sweetness. They don't have taste buds that taste or sense sweetness. So you'd have to have quite a bit. Now, of course, food manufacturers, the cat food makers, they do put a little sugar in because they know that the cat owners are going to be tasting the food before giving it to them. Okay, so...
Ron,
yes.
before you go on, I have an argument to make.
Uh-oh.
We have a cat, bless her soul,
Yeah.
and she's a fruit fanatic.
Okay.
And she particularly loves blueberries. So, in order to call her from the house if she's hiding, you shake the blueberry. Now, I swear to you, we have to crush them up to expose the flesh, and she will not eat the sour ones. She favors the sweet ones.
It could be the odor. I can't say for sure, or she could be part human. I don't know. And actually, that's a good segue into what my next piece is. We're going to talk about the minor things that are in honey. Honey has flavonoid chemicals, and those are the flavors, in parts per billion. Parts per million, we can measure the minerals and vitamins in honey. Parts per thousand, the different kinds of acids that occur in honey. And in parts per hundred, the dihydrogen monoxide. Now, how many are concerned that your honey is maybe 15 or 20% dihydrogen monoxide? Okay, dihydrogen monoxide is water. And then, of course, the sugars, which we're going to talk about in a lot more detail. But first, the flavonoids. So, our tongues taste sweetness, our noses sense the flavors in honey. And the flavor is due to a few hundred different chemical elements that that are parts per billion in a honey sample. And just as an example, down here I've got listed pentanol, furfural, and some other chemicals. If you had that in a honey sample and you had your eyes closed and you were tasting it, you would say, ah, that's buckwheat honey. If it had various cymines in it, it would taste kind of minty and kind of like acacia, or not acacia, kind of like canola honey. The hexagonal is a chemical that's more present in acacia honey than any other honey. So different honeys have different flavors, which we sense with our nose and not with our tongue. We taste the sweetness with our tongue. The parts per billion are all these different chemicals in various combinations, various amounts, and they give us that bouquet, or that taste, that flavor that we sense with our noses. Parts per million are the minerals, the vitamins, and even the pollen grains that are naturally occurring in honey. These are measured in parts per million. Pollen, by a chemist, would be measured as nitrogen in the honey. By a paleontologist, they would look through a stereo microscope and count the number of pollen grains they see. They could even tell you what plant those different pollen grains are from. Those pollen grains could range from a few grains per gram all the way up to 50,000 grains per gram, which is 50 million bits of pollen per kilogram. And some honey, the highest I've ever seen, I haven't seen the honey itself, but I saw the interpretation of it, at 43 million grains per kilogram of pollen in it. So mostly there's a small amount of pollen in honey, measured in terms of nitrogen by chemists, and it's the quickest and easiest and fastest way of getting a proxy. The reason they measure the nitrogen is because pollen is an amino acid, and amino acids are made of nitrogen and other elements. If they measure the nitrogen, they have a proxy for the amount of pollen that's in the honey. But let's look at the minerals that are measured in parts per million. Just as one example, looking at potassium, 200 parts per million on average. Some honey has as little as 100 parts per million, some has almost 600 parts per million. On average, there are about 200 parts per million potassium in honey. Well, we need 3,500 milligrams every day of potassium. You could get that entirely from honey if you're willing to eat 17 kilograms every day. So if you have honey customers coming to you and saying, yeah, you know, I like the darker honey because it's got more minerals in it, or does your honey have minerals, natural minerals in it? You can, yeah, it does, but you're going to sell them a lot of honey. They're going to have to eat this much every day. If they want to get the ascorbic acid that they need at least 100 milligrams a day. A lot of people like to have a whole gram, about 1,000 milligrams of vitamin C every day. You would need, for the minimal amount, you'd need 5 kilos. You have to eat 5 kilos to get enough vitamin C from your honey. So when you're selling your honey, you can certainly promote the fact that the enzymes have broken down the sucrose into fructose and glucose, which are much easier on our bodies, give us energy more quickly, and it's easier for us to digest. But you shouldn't oversell the fact that it's got minerals and vitamins. They are there, but in very small amounts. Where they make a big difference for us, though, is in the color of honey. On the top left, you see a picture of some really dark honey. That's buckwheat. And buckwheat comes from a white flower that's very dark, and it's among the highest in mineral content. Fireweed, coming from this purplish flower, is some of the whitest honey. So the color of the flower has nothing to do with the color of the honey, but the mineral concentration does. And graphically, I can show you here, I drew this up by taking 500 samples of honey. And for each sample, this is one sample by the way, that would be one sample of honey. So for 500 samples of honey, I calculated, or I found a calculation on the color of the honey. And the darkest honey is at the top, the lighter honey is at the bottom. So the darker honey has more ash, or minerals. The chemists call it ash, it's minerals. More nitrogen, the chemicals call it pollen nitrogen. So as you get darker honey, you've got more of these other materials in them. As you have light honey, look how closely these honeys are clustered to 0. So almost no ash, almost no nitrogen or pollen particles in it, and you have the whitest honey. So that's the way, that's the main influence for the color of honey. Honey also has acids in it. These are all totally natural. If you were to go out into the forest and climb a honey tree and chop off a chunk of raw honey that's never been touched by a beekeeper and therefore not contaminated in any way, and took that home, put it in the lab, you would find that it has acetic acid, which is basically vinegar is dilute acetic acid. A raw sample of natural honey has butyric acid. How many people here use butyric acid when you work your bees? Butyric acid is the chemical that we call bee-go that stinks so badly and chases the bees out of the hive. So when you're using this smelly stuff, you're actually using a natural product, butyric acid, that naturally occurs in honey, not as concentrated as what you put on those boards when you chase the bees out, but it's there. And a lot of you guys and gals are using formic acid to kill mites. Formic acid is totally a natural treatment for killing mites because it's one of the fundamental acids that's always found in honey. So if you slop it around and you're killing mites and some of it accidentally gets in the brood chamber and ends up one day in the honey, maybe it was there before. So most of you guys know what a pH is. That's a way of measuring acidity and stuff. A pH of 0 is battery acid. Most honey is not like battery acid. If it is, you're doing something wrong in the honey house. So where honey is showing that acid that we just talked about is in a range of about 3 to close to 6. In this range, this is the range of pH that most natural honey has. And something that I find that I'm still puzzled about this, and maybe somebody can come up with an answer or tell me why this is true, but here we go. Clover and alfalfa, we produce that here, right? That's some of our main honey. And the clover and alfalfa is the most acidic of the major types of honey in the world. It's about as acidic as orange juice. You don't taste the acid, like you don't taste that because honey is sweet, but it's there. And the pH of clover and alfalfa is around 3.3, 3.4, somewhere around there. And on the other hand, goldenrod and blackberry are among the least acidic honey. But here's the puzzle. If clover and alfalfa are so acidic, why is it that they only secrete nectar and only grow well on alkali soil, whereas goldenrod and blackberry produce a non-acid honey and they only grow well in acid soil? So I have no idea. Like this, I'm just throwing that out because it seems so strange to me. And in fact, I was so puzzled with this that I took a data set that had 500 honey samples in it, and each one had a pH, and each one was from a certain part of the United States. And the honeys that have the most acid are these guys in here. It also includes a little bit of West Virginia. And I can explain that as because it comes from a strip mine of limestone. And all the soil in here is lime soil. We know that. Prairies have alkali soil. But the pH of the honey is the most acidic. Whereas where the acid soils are, like in the Appalachians and through the Rocky Mountains, those soils are pretty acidic. And yet the honey is not acidic. I don't know the answer to that. I'm just throwing it out and just kind of something somebody here might decide to turn into a research project. Okay, looking at the water in honey. Water is not added to honey by bees. The water comes in because it's in the nectar. You sometimes see bees gathering water. They do that to cool the hive and also to mix in with the pollen so they've got something they can feed as bee bread to the larvae. But it's not put into the honey by the bees. Water is a natural component of nectar. Nectar can be from 20 to 95% water. The rest is sugar as the bees bring it in. And of course a few minerals, other chemicals. And honey ranges from about 13% up to about 23%. When it reaches 23%, legally you can't call it honey. The legal limit is 18.6. So if you get pulled over by the honey police, they're going to check. You better be under 18.6%. This chart just shows you distribution. Most honey falls around 17, 18%, in around that area. Some honeys are a bit higher, and they shouldn't be. If you end up in that position, you've got a problem. Your honey might sour rather quickly if the moisture level is that high. And some honey is quite low, particularly the honey we produce in this area. We produce pretty much a low because our climate is drier. We produce a low moisture type of honey.
So what would you call 23%?
Oh, let's call it nectar that the bees should have taken care of. You really do have a problem. There are a few different solutions. One is you can heat it up to try to kill the yeast, which would ferment in that, and that'll stabilize it a little bit. You can freeze it and then take it out as you need to use it. You can mix it in with other honey that's much drier and try to reduce the overall moisture content in the honey. So you've got a few tricks you can do, but mostly you want to check your honey with the refractometer as you're bringing it in or out in the field, and bring in honey that's mostly sealed and is not going to be souring on you later on because there's too much moisture in it. These are the sugars that are in honey. On average, we looked at all the honey in the world, on average, sucrose only makes up 1% of the typical honey sample. Maltose is about 7%, glucose 31, and fructose 38. There's a range here though. A lot of honey has almost zero sucrose in it, whereas the honey we produce in our area approaches 2 or 3% sucrose. And I've seen honeys as high as 7 or 8% sucrose. And that's not because people have added sugar to it, it's just the way the nectar comes in and the bees have handled it, so it's higher in sucrose. The others can range a lot too. Maltose might be close to 0 or it could be almost 20%. And these other guys will range too. But let's look at the sugars just quickly a little bit so you know what we're talking about. Sucrose is table sugar. We decided earlier that the sweetness level of sucrose is 100, and it makes up a very small component of typical honey sample. This is maltose, or malt sugar. The maltose has a sweetness of only 40, so it's a very bland sweetener. It's a little bit darker in liquid form, and you can make maltose out of glucose if you heat it too much. So when you heat up your honey, you're caramelizing it, you're darkening it, and to some extent, you're creating maltose too. This is glucose. Glucose makes up about 31% of the typical honey sample, and its sweetness is only 74 compared to honey, sucrose being 100. And finally, fructose is the biggest component in most honey. About 38 to 40% is fructose, and fructose is also the sweetest natural sweetener of any sweetener in the world. There are other sugars that occur in honey, and one of the most abundant is melazitose. It's really abundant in some honeys and absolutely missing in others. Our honey from the Calgary area has 0 melazitose in it, but it's a major honey in honeydew. How many people in here know what honeydew is? Okay, not too many. So honeydew is honey gathered by bees, but it's not from flowers. It's from the sap that's created by aphid. They're plant lice. They're sucking sap, sweet sap, sucrose, out of a plant. So in some areas, particularly forested areas, there are a lot of aphid living in the trees, and they're sucking the sap, and some of it, a lot of it, leaks out of them and splashes down on leaves and grass and so on. And while it's still wet and sticky, honeybees come along and gather it. And it sounds kind of trivial, like, okay, so there's a little bit dropping out, but there are actually millions of pounds of honeydew produced, particularly in Europe. And in certain places, people who grow up with this really prefer it. For them, this is what honey should taste like. It's a stronger flavor, it's not as sweet, because melazitose is a trisaccharide. Remember we looked at the disaccharide, the 2 molecules stuck together, that was sucrose, and the monosaccharides are the fructose and glucose. This is actually a trisaccharide, and it's not as sweet as the others are. But it still makes some nice honey for people who prefer that style. A lot of different colors and different flavors. These are our honey, your honey. This was from the very first honey judging program that we had right here 7 years ago. All of these were contributed by members of Calgary Bee Club. You can see a wild variety of different colors, different flavors. Now you can certainly pick out which ones probably have the higher mineral content. And with a refractometer, you can pick out which ones have the most moisture, but you're not going to be able to pick out which has the most fructose or glucose just by looking or smelling. Maybe by tasting, maybe not. We'll get into that, you'll see why. So the only way that you're going to know which of these has the most fructose or glucose is doing a chemical analysis. And chemical analysis is not cheap. If you want to know the pollens in a honey sample, you can send them off to a palynologist and they'll look under a microscope, and for 60 bucks, they can analyze your sample and tell you what pollens they think they see and what proportion. You can also get the sugars at a chemical lab. You can get the sugars assayed, and they can tell you the percentage of fructose, glucose, sucrose, maltose, and other sugars. Altogether, that's about 200 bucks per sample. In the back room, there are 30 samples of honey being tested right now, so $200, 30, that's $6,000. I don't know if our club has enough money, but for $6,000 we would know the sugar content and pollens of each of the samples that were brought in here. Probably we would not be able to convince anybody to spend that money, and I certainly would not spend that money to find out what sugars are in any particular sample of honey. So instead you go to other resources. And one of the best resources that I've ever seen is this book called Composition of American Honeys. This book is old. I was a kid when it came out. I grew up in the States. I grew up in Pennsylvania. My father was a beekeeper there. And he was one of the people who sent in honey samples to the USDA to have it analyzed for pH and ash and minerals and also all the different sugars that were in it. He and 390 other beekeepers all sent in their samples at the same time, to the same lab, to the same people, to have it all analyzed identically. It was the first really big comprehensive study of honey ever done. And as a reward for sending in 3 samples, my father was one of the real keeners because most people send in 1 sample. He sent in 3. They in all had 505 samples to look at and analyze, test the color, the moisture, everything else. And his reward was a copy of this book. And I remember when I started working on this story for you guys and trying to think of what was the, what's the sweetest honey, and I remember this book. So I got really excited because I wouldn't have to spend any money and I had a resource, and here it was. So I found my book because my father gave me all his bee books, and here it is. And it doesn't look like it should because my little sister thought that it was a coloring book. She really thought it was a coloring book. Hey, she got an A+, okay? But I thought, okay, no problem. No problem, Joanne. You didn't ruin my life. She's 18 months younger than me, so you figure out whether she ruined my life or not. I could write down all these numbers because I could see them. See 24.04. I could write this all down in a spreadsheet, figure it all out, and then I realized that my book went from page 34, page 55, and my dear sister Joanne has the other 20 pages somewhere. So, you know what? Everything is on the internet these days. Here's the original, where Joanne didn't color it. Came from the University of Virginia. It's on the internet. You guys can look it up if you're curious. It's all there. I transposed the numbers, but it's got everything you need. It's got the moisture, the sugar levels, everything. And it tells who produced it, and the producers said whether they thought it was from alfalfa, or tulip poplar, or whatever. Does this look scary to anybody? Yeah, a few people. Okay. A data scientist would look at all those numbers. There are actually 15,000 data points in that little booklet. And they would start plotting them together to try to see what kind of trends. And look at this, there is a trend here. Not too many trends, but there's one here that jumps right out at you. This is how maltose and glucose are related to each other. If you have more maltose in the honey, then you're going over to the right on here, more maltose, you have less glucose. Anybody want to guess why that might be? Why would some honey have less glucose and more maltose? And it's a real linear, look at that relationship. The correlation is really good. It's an inverse correlation, more maltose, less glucose. I don't know the answer to that, but I'm guessing that since maltose is a disaccharide, and it's not made of fructose and glucose, it's made of 2 glucose stuck together, that some of the glucose in honey has merged together and created maltose. So some of the glucose disappeared, and instead you've got maltose. And that's why you have that inverse relationship. So anyhow, a scientist would look at this and they'd look for trends and try to figure out things like what's going on. Here, look at this, color. On this column, we'll go down the column, like this. We've got color. If you look at the ash or mineral content, there's a nice correlation. There's a little less of a correlation with the nitrogen, and some correlation with the pH. Anyhow, I'm not going to go any further with this, but you can see that with all these sample points, you can start digging around, and sometimes useful stuff falls out, like this right here. What we find is, from the same data set, that coloring book that we used, if I look at the granulation of the honey, this is the most granulated honey at the top. And as honey becomes, if you have a lot of granulation in your honey, you're likely to find you've got a lot of glucose in the honey. Those two correlate really well together. So high levels of glucose, lots of granulation. Low levels of moisture, according to all these data points, low levels of moisture also gives you more crystallization. So how do you use that? We've learned something from that data. We know that if you want to avoid granulation, you should look for flowers that have less glucose in them when you're producing honey. And also, you shouldn't be too afraid of having honey that's 18% moisture. It's still legal, it's still safe, it won't sour, and it's probably not going to granulate as quickly as others. That same data set, I told you there were 505 different samples. 15 of those were honeydew. If I take out the 15 honeydew, because it's really kind of odd honey, it has different kinds of sugar balances in it, and only look at the 490 that were from flowers, floral sources, the thing I want you to notice here is how much range there is around the mean. For example, the moisture, you go from 13% up to almost 23%, but the average is 17. But even more significantly, look at the sucrose. There is honey in North America that has almost zero sucrose. And there's other honey that has almost 8% sucrose. But the average is around 1 or 2%. Maltose is kind of similar. It can range from almost 0 all the way up to about 18%, with 7% being kind of the midpoint. Now, why I'm pointing out these is because the amounts of sugar vary quite a lot from different floral sources. And because each of these sugars has a different sweetness value, that's how we get different levels of sweetness in different honeys. But we'll get back to our main story, and that's the world's sweetest honey. And yeah, that's our 10-year-old daughter there in that picture. So she was in England trying to find the world's sweetest honey, and it's not there. But we'll find it. We'll find it with a formula that looks a bit like this. Okay? So if we take the various levels, like we'll look down here for just a second. If you look at alfalfa as an example, it typically has about these proportions of these different sugars, and these are the sweetnesses. If we multiply it all together, when we divide by the total amount of solids, we end up with a number, and that's the sweetness value. The point here is it can be calculated. Does anybody have any questions about that formula at all? Okay. Anybody?
MC squared.
All right. I just wanted to see if anybody would notice this. Of course, this wasn't in my equation. It doesn't help. It's just a reminder that honey is energy, right? That's what we're talking about. And energy, E equals MC squared. So, the world's most average honey, if we took a little bit of every type of honey in the world, put it in a big pot, stirred it up, and then took the fructose, glucose, and sucrose, and maltose, and maltose, and all the higher sugars and all the lower sugars, and we added it all together and divided by the total amount of solids, we come up with 115.55, almost identical to alfalfa. So the average sweetness of honey is right around 115. And this kind of gives you an idea that most honey is clumped around that center. So the honey we produce is near the center here. These guys here are outliers that are not quite so sweet. They're still sweeter than sucrose. Remember sucrose has a value of 100? And these guys are all honeydew. So honeydew, because of the types of sugars in it, still sweeter than sucrose, still sweeter than table sugar, but not as sweet as most honey. And over here, we have the prize winners for tonight. And those are the sweetest honeys in the world. And we'll get to that in just a second. So here's my chart of the major honeys that I had data for. It included those 500 different samples from that ancient book that my sister wrote in. And it also has several thousand samples from a European study. And each of these, like we just look at one for an example. Let's look at the canola. I didn't have American numbers, but I had European numbers. They produce canola honey, mostly in Poland, in Europe. And there were like 300 honey samples, and we took the average. And the average amount of fructose is about 38. That's quite a lot, actually. But it has the most glucose of anybody on the list. Over 40% of the honey, of the sugars in that honey, in canola honey, is glucose. So you can arrange these guys in order. The lowest ones are the honeydew. Then we have blackberry honey, dandelion honey, some kind of odd honeys. And then down here again we have the winners, which I'm still not letting you see yet. We'll know in a few minutes. But look at the fructose. See how the fructose has gone way up here? It's up into the 40s for these samples of honey. And for honeydew, the fructose is way down around 31, 32%. Okay, runner-up. Number 2 in the world is a honey called Tupelo. Anybody heard of Tupelo honey? Just one person in here? Okay. This is a really famous signature honey from Florida. It's produced along the Apalachicola River in North Florida. And the Tupelo tree grows in the Apalachicola River. And the tree grows right in the river. So in the old days, I took this picture right out of a 1915 bee journal. And it shows the beekeepers putting their honey on a barge, or the bees on a barge, and floating them down the river to catch the honey from these flowers. See the flowers up here? So it produces this really unique, very sweet flavored honey called Tupelo honey. Every year in Florida, about 2 million pounds of Tupelo honey is produced, and about 10 million pounds is sold. So when you stop at a shop and you see honey labeled Tupelo, maybe. And here's the sweetest honey in the world. It comes out of Central Europe. This photograph's actually in Hungary, and the sweetest honey is from black locust, as we call it in North America, or acacia, as it's known in Europe. It's beautiful honey, high fructose. It will almost never granulate, and it's very, very sweet. So some people who enjoy honey, they actually find it too sweet. They think it's something almost artificial in it, but it's natural, very natural. It grows on this tree, has this beautiful white chain of flowers dripping down off of it, and the bees go wild for it. It only blooms for about a month in May every year. And in Europe, they produce 100 million pounds. Sell it for about 10 bucks a pound, so it's a $1 billion business producing acacia honey in Europe. They produce 100 million pounds in Europe and only about 1 million pounds in North America. But here's the really weird thing. 300 years ago, there was not a single acacia tree in all of Europe. It was brought over from the Appalachian Mountains as an invasive species, brought into Central Europe. It went wild, and the bees went wild with it, and they produce a lot of honey. Backing up here a minute. This is our Tupelo. The Tupelo tree is totally native, probably been in Florida for 1 million years, but the bee is not. The bee is an invasive species. It was brought from Europe to North America. So you see what happens when we mix things around the world. It's not always a bad thing. They tried to shut down the acacia industry, the honey industry, in Hungary, in Romania, in Poland, in Croatia, and Slovenia, where most of this honey is produced. The people trying to shut it down were very serious environmentalists. They don't blame them. I mean, they've got a thought that you can think about. Their idea was that these trees, and there are millions of them because they're producing that much honey, millions of these trees in Central Europe don't belong there. But the biggest pressure came out of Germany until it was pointed out to the people in Germany that all the corn and all the potatoes and all the tomatoes that they were growing were actually from North America too. Okay, so we got there. This is the sweetest honey based on chemical analysis because it's very low in maltose and very high in fructose, and that makes it really sweet. So Tupelo here is on my list. It's scored very close to the others, so there's not much difference between these guys. A little further down the list is sage, which is a flower that grows in the mountains of California, and then on down, down, down. We are somewhere near the middle of this area. Flip ahead. So our honey is Canadian honey, pleasantly average. You can be proud of it because it is, I think it really is about the best honey in the world. And this coming back, we're ending now back to the honey that I think is really the best, not the sweetest, but probably the best. Anyhow, that brings us to the end. Thank you. I can take a few questions if you have any. Yeah?
I just have one about the minerals. So do those largely come from water from the ground through the plant, or do they come from dust?
That's a really good question. The question is, where do the minerals come from that's in honey? Is it from dust, or is it from the water and from the ground? And apparently, it's coming up into the plant from the ground. But what's really neat is that you can have a field of buckwheat right next to a field of alfalfa, and the buckwheat honey will have all those minerals in it. The alfalfa honey is almost white and won't have very many minerals at all. So it's the plant that is the conveyor of those minerals, and it either pulls them up preferentially or differentially and puts them into the nectar that the bees are gathering. But it does come out of the soil, and it's dependent upon the type of flower that's producing the nectar.
Is there another name for the tupelo tree?
The question, in case you didn't hear it, the question was, is there another name for tupelo? And I don't know of another common name for tupelo, for the tree that grows in the Apalachicola River in Florida. But the question was, is it related to basswood, or is it basswood? And no, it's not. Basswood is what Europeans call a lime tree or linden tree, and it grows quite a bit differently. It doesn't grow in water. Basswood does produce honey. It produces a light honey, but not nearly as sweet. And in fact, I think it's on my list. It just popped back here. Yeah, it is. So basswood's not very sweet at all. It's right here. And its sweetness is about 115, below 115. So it's quite a bit less sweet than tupelo honey. Any other questions? Yes?
I'm curious about the study that was done that you had your little booklet.
Yeah.
If that study has ever been updated in the last 10 years at all.
It hasn't, and it's been more than 10 years since me and my little sister were that But it's an old study.
It would just be interesting.
It would be.
Agriculture has changed.
Agriculture has changed a lot. In that study, they never list canola. It didn't exist. Canola didn't exist until 1973.
I'm sure the latest president will make study and science
Yeah.
a priority as we go along.
Well, we'll see. That would be a real bonus, wouldn't it? Anyhow, the question, in case you didn't hear the question, it was, has that study from my childhood been updated? And no, it hasn't. I've looked and looked and looked because I wanted to have more current data. And things did change a lot in the States. At one time, at the time of that study, there were 25 million acres of sweet clover planted from seed for cattle. And today there is less than 5,000 acres planted from seed because it just ran its course. People use other sources for cattle feed. Other things changed. Soybeans are now in the picture. They produce a bit of honey. So think it definitely should be updated. You can see the cost, but there would have to be a real demand and need for it. At that time, back in the 1960s, there was a big need for this analysis because they really didn't know what was in honey, and they wanted to know across North America, well, across the states, what the proportions of sugars and pH and all that was. Is there another question? Yes, in the back there.
This honey here looks like a beautiful cream honey.
It is. It's creamed honey.
Okay, my question is, I've made creamed honey, and it will be soft, you can squeeze it. The next time it's so hard, you can't squeeze the container. What makes the difference? Sometimes it's nice and it looks like that.
Yeah.
Sometimes it's hard.
Yeah,
Is
that's.
it a proportion of moisture? Or?
No, it's just magic. No, I can't answer that because I don't know exactly what you're working from, but it could be the moisture level in the honey. But if you do it all the same, usually you do end up with the same product in the end. Next time you have some really nice results like this one, do you save that as your seed for the next time that you're making creamed honey?
Once in a while, I use the same seed, otherwise you get new seed, and I always get new seed that's nice and soft,
Right?
and it
Right.
still can end up hard.
Yeah, yeah.
Whoever makes creamed honey, what is the ideal moisture level for creamed honey?
Okay, there probably isn't an ideal, but if it is a little bit higher, like closer to 18%, you're probably better off. But here's how you make creamed honey, is what you do is you need about 10% of a seed, like what's in this picture here, that's nice and smooth and soft and runny. And you heat up your other honey that you want to use to convert to creamed honey. You heat it up till it's totally liquid. There has to be absolutely no old granulation left in the honey that you're working with. Now, so next thing you do, you stir it in. Brenda Peach is, how many people know Brenda Peach? Do you guys, some of you know her? She's, yeah, okay. She's a club member, and she's, this is her honey here. And she's made it a little bit of a sideline business with her honey, is to create this. And she told me how she does it. And she uses about 10% of her best creamed honey from the year before. She heats up the honey till it's totally melted. She pours in the creamed honey and mixes it for about half an hour. Thoroughly mixed with the mix master. Then she pours it into these buckets, and then they go immediately to the basement where it's cool. It only takes about 2 weeks, and it sets just like what you see here.
Hey, Ron?
Yes?
If you wanted to make buckwheat honey, could you guesstimate how much acreage you need, say, for 2 colonies? 4 boxes, say?
Yeah, did everybody hear the question? The question was, if you want to make buckwheat honey and you had 2 hives of bees, how many acres would you need to produce it? Well, here's the thing. Buckwheat honey is not as attractive to bees as sweet clover. So you would want to be in the middle of a huge field so big that the bees would get tired flying out of the field and they would stop and pick up the buckwheat. So typically, as a rule of thumb, it's like about 2 or 3 acres of any plant is enough to fully feed a hive of bees. So if you have a section, 640 acres of alfalfa, you could actually put 200 hives of bees there. And they would all do just as well as if you only had 2 hives of bees there. You can't really overstock these plants too easily. The question really isn't how much acreage. You would want to have at least, I would think, maybe 10 or 20 acres of buckwheat. But you'd want there not to be other floral competition because the bees would probably ignore the buckwheat. Okay, anything else?
Back to the creamed honey a bit there.
Yep.
10% of your seed honey, you're going to heat that to 140 or so also?
No, you don't heat it. So the heating is, that's a good question, Jim. So just to be clear, when you heat the honey up, that's your new crop honey that you want to turn into creamed honey. So you heat that up so that all of any bits of granulation that have started, or even if you have, like it's midwinter and you pull up a pail of really hard granulated honey, you can totally melt it down, but when you do, totally melt it down. So there isn't any coarse granules left in it because those will work as seed and your creamed honey won't be as nice, it'll be chunkier.
So the creamed honey you put into that liquid honey then?
After it cools, yeah.
It's soft enough to mix.
And then mix it in, exactly, yeah. Okay, I think we're probably, I'm sorry, one more question.
How many linden trees would you need in order to have that kind of honey?
Oh, I can't answer that, but I'm guessing there are probably 100 trees in an acre, something like that in a forest. So you would probably only need 100 or 200 to fully satisfy a beehive. Yeah. Okay, I think we'll stop there. Thank you.